think we're in good shape. What's going on, y'all? Rob here, Square Wheels Automotive. Thank you for coming back to the channel. Let's get some housekeeping out of the way. So first things first, welcome to all the new people who have joined the Square Wheels family, especially those that have joined in response to the lighting on crack video. Completely unexpected, overwhelming response from that video. The numbers are still running up. If you haven't seen it, go ahead and check it out. I'll link it up here in one of these corners. But yeah, so to answer a lot of your questions, yes, officially we are working with Glowe Industries to put together a kit specifically for the Infiniti Q50. It'll be based on all the measurements that I did, and we'll be picking the exact products for you guys to be able to replicate this interior project on your Infiniti Q50. Now, I do appreciate that lots of you guys have seen this video that don't drive Infiniti Q50s, and to be honest, that intimidated me a little bit. It kind of scared me because I wanted this channel to go wider and accommodate more vehicles, but I wasn't expecting this to be it. So no matter what, I'm putting together a wiring video, so when these products are released, you will be able to follow my wiring video to get it done. But I realized as I was creating that wiring video that I actually learned a lot over the last year related to addressable LEDs, 12 volt wiring and all that, that really made this interior project possible. And I think it's going to be helpful to give anybody that's interested in it some foundational knowledge, because to be honest, there isn't a lot of that information out there. So today I'm going to walk through messing with LEDs 101, basically, where I'm going to cover wiring and connectors. I'm going to cover LED strips and the different formats that they come in, and I'm going to cover controllers. These are all essential things that you need at least basic knowledge in to be able to do a project like this interior project. So after watching this video, you'll be well equipped. You'll have a good understanding of all these pieces and how they go together, so that you'll be ready to do this interior project if you want to do it, but also design and troubleshoot any projects that use addressable LEDs, should you have the desire to do that in the future. So think headlights, think underglow, think trunk setup, think anything you can think of. It's basically this basic knowledge that I use to design that interior. So with these tools, you can go nuts with it. So sit tight, don't need to take notes or anything like that. As with all my videos, I leave chapters along the bottom, so if you need to jump to something, or if you need to jump back to it, just check out the chapters and you'll be able to find your way. As always, if you're not a member of the family, please, if you find this valuable, hit that like button, hit that subscribe button, and I'll see you on the other side. Thanks for checking me out. Okay, so first things first, let's talk about wiring. So for most of these LED projects, they're going to use a 3-wire system. It's going to look something like this. And each of these 3 wires has a distinct purpose. The red wire, and it's usually always red, is going to carry your power. The white wire, which is sometimes black, will carry your ground. And then the green wire will carry your data signal. These are the basic elements that your addressable LEDs are going to need in order to operate. So power and ground is just going to turn it on and off, basically. Nothing really to see there. The interesting one is the data in the middle. That's going to tell each individual LED in your strip what to do, whether it be change color, turn on or turn off, change brightness, change intensity, whatever it is, that data wire is going to tell it what to do. So it's very important. Now, depending on the application, these wires do come in different gauges. Now, if you're doing a smaller LED project, like say headlights, where you've only got like 18 inches of LEDs, then you don't need to be terribly concerned with the gauge of the wire. But for those larger applications like Underglow or the crazy interior that I did, you are going to want some heavier gauge wire. And the reason is the longer you're sending electricity over these wires, the voltage tends to sag especially if you've got multiple integrated circuits on your LEDs, kind of pulling on that. So you want a nice, thicker, heavier gauge wire for your longer, more complicated projects. From the wiring, we can go to the JST connectors, and these connectors usually sit at the end of your long runs of wire, and it's what you're going to use to connect your wiring to your actual LED strips. They click in really nice. Another thing to keep in mind too is the gauge of these JSTs. So again, if you're doing long runs of electricity and you're connecting your long run to the end of a JST connector, then your new bottleneck becomes this connection here or the JST connector. So if you're running heavy gauge wire, make sure your JST connectors aren't going to become your bottleneck, because each one of these that you connect introduces resistance, whether you like it or not, and that can end up in having voltage sag towards the end of your lines. So now let's talk about everything you want to know about the actual LED strips. First thing you're going to want to know about is the voltage of your strips. Now generally for automotive installs, these strips are going to come in either 5 volt or 12 volt variety. And you're going to want to know this up front when you're doing your project, because if you feed the wrong voltage to your strips, they either won't work or they could just fry and go up in smoke, and then you'll be asked out and have to reorder stuff. So definitely know that up front. If they are 5 volt strips, chances are they will come with like a step down converter, but if not, you'll have to step down that voltage from your battery. Next up is number of pixels. So I just started calling this pixel density. I don't know if that's what other people call it, but basically all these strips have kind of varying number of pixels per meter. And this is less important when you're not installing it somewhere where you'll actually see the individual pixels. So if you're using it for like under counters or underglow, it doesn't really matter how far apart the actual pixels are. So what we're looking here is some glow underglow, and each of these white squares is where the light comes out. It's the actual LED, and you can see that they're fairly close together. But if you look at this new hot shit, so this is the new glow rope, you can see how tight these pixels are together, and that's what makes this one a perfect install for something like headlights, where somebody will be looking directly at the light, and if the pixels are really close together, then you get a nice tight solid beam and you don't see any gaps in the lights. While I'm here, I'll just plug it. I am working on a new headlight build with this new glow rope. It's coming soon, so stay tuned. Okay, now LED strips can be cut down to the size you need for your application. Now what you'll see when you look at the strips is that there's little cutting points, and it's right where these solder pads are. Anywhere you see these cutting points is where you can cut your LED strips down to size and make them work for your application. Taking a look at the glow rope here, you'll see that the cut pads are after every individual pixel, and this really allows you to fine-tune your installation and not be, restricted or have any LED strips hanging off anywhere. Now after we cut, we can zoom in a little bit and see that each of these soldering pads is actually labeled, and this gives you a good indication of how these strips are connected to the actual wires. So you'll see it's labeled 12 volts, DI for data input, and GND for ground, and that's going to coincide with the wires that we talked about. So the red wire, the green wire, and the white wire will solder up to those pads and give the strip everything it needs to light up based on whatever the controller is telling it to do. Now this may be extra info, but I solder my JST connectors onto the ends of my strips, but realistically, if you're here for that interior Q50 kit, all this stuff will come pre-soldered, and you'll have all the connectors on all the strips that you need in order to get the job done. Now, the last thing to talk about, since we now have our strips and we now have them wired to whatever we want to wire them, and we now have them wired, we need something that's going to tell them what to do. And that's where the controller comes in. Now, this is the SP602E. This is what Glowe Industries calls their UFO controller. But there's tons of different controllers out there. This one is the most comparable to a Blue Ghost light controller, in that it has 4 different channels, which is actually a benefit that Blue Ghost doesn't have, and it accepts 4 triggers. And what these triggers do is allow you to provide it a signal on each trigger, and it can do something to 1 or more channels of the LEDs. So that sounds really abstract. Let me give you an example. So let's say we've got all kinds of LED strips hooked up to channels 1 through 4 on my controller. If I send a signal to trigger 1, I can set it to run a party mode, or pretend to be turn signals, or turn off. Basically, you can really use these triggers as a part of your design. So it really kind of gives you a bit of versatility and creativity in your project. But let's just go down the controller and talk about all of the inputs and outputs, starting with the left. So most of these controllers are going to require power to run. So on the left hand side, you've got your power, and you'll see that they can run on anything from 5 volts all the way up to 24 volts. Obviously, to accompany the power, you are going to want a ground, and for these projects, it's really important to have a good solid ground, and even inject grounds, you know, if you do have longer runs, just to make sure that you're not introducing any flickers or anything weird in your setups. Also on the left hand side are the triggers, which I just explained. So these triggers can be 5 volts, they can be 12 volts. It's just basically a 1 or 0. When there's electricity coming through that trigger, it's going to tell the controller to do whatever you pre-configure in the app. And whenever there's no data coming through, then it'll just default to whatever the default is. You've got 4 triggers. I believe on the UFO controller, the first 2 are turn signal, or you can override them and just do whatever show mode that you want. Now on the right hand side, you also have power and ground. Now this is provided to allow you to power and ground all of your LED strips if you choose. So for basic installs, that's okay. The only downside of that is that now all the electricity is running through your controller, and sometimes that can prove to be a bottleneck. Sometimes it can prove to, you know, create heat issues. So there's other ways to go about that. Maybe I'll cover that in a separate video, but just looking at the controller, it does have a power and it does have a ground that can power your LED strips. All that's left on here is the data channels, and there's channels 1, 2, 3, and 4 on this controller. Now you can set these channels any way you want. So on my Underglow, I had channel 1 for my grill, and then channel 2, 3, and 4 just going down the left and right hand side of my car. On my interior, I did something a little different, where each seat in the car, so there's 2 in the front and 2 in the back, each of those is separate channels, so that I'm able to control them separately or in unison if you want to do that. But these controllers are really cool. I've messed with a few of them now. These 2 are definitely my favorite. The one cool thing about this one is it does have music response. So some of these have microphones inside them. Some of them will use your mobile phone's microphone to be able to respond to the music. So another really cool feature that, again, applies some creativity to your projects. All right, so we've already talked about wiring. We've already talked about the different LED strips that you can potentially have. So you should be able to run the wires through your car and get the LED strips exactly where you need them. We haven't talked about how to get the LED strips to actually turn on and display the colors and animations that you want them to. And that's where the controller comes in. So this is an example of an addressable LED controller. This is the SP602E. It's pretty well featured. It's one of the controllers that's offered by Glowe. I believe they call this one the UFO controller. But regardless of what controller you go with, what brand or what vendor you get it from, they're going to be largely the same in that they take some inputs and they put some output out. Usually they'll connect through Bluetooth to your phone, and some of them come with handy remote controls, so you can skip opening the phone app and just pre-program stuff into the remote control and use it that way. But what I'm going to do is walk you through how to wire this controller, because if you can do it on this one, you can probably do it on 9 out of 10 of the controllers that you'll run into, because this one has most of the features and functions, or more features and functions than most of them. So I'll walk you through the power, I'll walk you through the triggers, and obviously I'll walk you through the outputs on this side. So what I'm going to do is switch to the desktop overhead cam and we'll walk through wiring this controller. Sit tight. Okay, so again, this is the SP602E and we are going to walk through the wiring of it today. So I always think it best to work from left to right when I'm wiring a controller. So let's start at the very beginning. So on the left-hand side of this controller, you're going to see VCC. Basically that means that's where it wants the power to come in. So what you're going to want to do is provide power to the controller, and in turn on basic installations, providing power to the controller will send power through the controller to the LED strips, which we're going to connect over on this side. So first things first, what I'm going to do is get so these controllers will tell you the range of voltage that you can accept. Now normally, well, it really depends what vendor you go with. I go with exclusively Glowe Industries LEDs. Now their entire portfolio is all 12 volt LEDs. So I'm going to provide this with at least 12 volts of electricity. The cool thing about it, for most car installations, you're getting 12 volts wherever you tap. So this is perfect, or Glowe LEDs are perfect for car installations. They'll actually take up to 24 volts, I believe, and this controller can take up to 24 volts. So I've got a little converter here. I'm going to hook up at least 12 volts to this VCC port, and then you'll see at the very bottom here is a ground port. So that's going to be step one, providing power to the controller. I'm going to take my leads. Now pretend that this white one here is your 12 volts coming from, your car, and this is your ground from a secure ground that you've got in your car. What I'm going to do is plug them in, and so now we've got hot going in, and what I'll do is plug the ground in, and it should be grounded. And obviously I'm inside on my bench test, so this is going to be similar but not exact. But now this has power. So if I take my trusty multimeter here, I can confirm when I hook this up to power and this up to ground, I'm getting a nice 20 volts, which is plenty. It's probably more than I need, but I know that glow strips can handle it, at least for this test, so I'm not going to blow any time stepping it down. But yeah, so step one is done. We've provided power and ground to our controller, and a good way to confirm that this is working is by getting my phone out and opening up the app that is accompanying it. So the app for this one is called Bandland X. Don't ask me what that means. So you can see here it's scanning and it looks like it's detected it, so I'm going to try to connect to it. Connecting. Now I'm in SP602E. I can interact, I can turn channels on and off. Obviously it's not going to do anything, but now we can see that I am connected to the device. So I know for a fact now that my power is working. Okay, on to the next step. Now we've got power and ground going to our controller. Now we want to connect our strips to it. So on the right hand side here, you've got power output, and then you've got ground output if you need it. Now on basic installations, what you can do is connect all your strips to the power output here, so the red wire from your strip. So now we can take our trusty JST connectors, and these are, I guess they're considered male because they're poking out. Poking out, they're any out, whatever. What we can do is take these connectors and connect it right to the strip. Now this is going to be, a very condensed desktop version, but this is where you'd run your long run. So let's say for your data 1, that's your first channel, and let's say you want to run that to the driver's side of your interior, or the front bumper for your Underglow. That's when you would hook up one of these, and then you'd run a long wire and then put one of these at the end of the long wire, and that's when you'd be able to hook it right up to your LED strips here. So what I'm going to do is just simulate that on a desktop for you. Step one, unscrew power, unscrew data 1, and then unscrew the ground. And what we're going to do is hook the red into the power, as we know, right? The green into data 1, and then the ground gets the white. Now in doing that, we are taking the power from the power, the ground from the ground, and the data from whatever we're sending in the app, which is nothing right now, and we're sending it through this JST connector. So now when I hook this strip up to the JST connector, we've got juice, right? So again, I hooked it up to channel 1. If I turn channel 1 off, channel 1 will turn off. If I turn it on, channel 1 will turn on. And then you can jump between whatever scenes you've got configured in here. So let's see, what are we telling channel 1 to do? So we can do music response, we can do twinkle stars, whatever the hell that is. So congratulations, you have just wired one channel to your controller. It wasn't too hard, was it? So what if you want to do an additional channel? Let's say you've got one strip that is going for the crest of your headlights, and you've got the brand new, soon to be available for sale, crescent for your Infinity Q50 headlights. Ha ha ha, what you know about that? Yeah, attention to detail, like that. Okay, so let's say you've got one of these and you want to run it again through the exact same controller. What we're gonna do is the exact same thing. So take another one of these JST connectors and you're gonna do the same thing. So you want power going to power on here. you want your data, the green one, going to, let's call it channel 2, right? We'll put it in channel 2 here. And then obviously your ground is going to go to your ground. So I'm just going to go through that real quick. I won't bore you with all the play-by-play. So power. Now, it's not the end of the world to plug, you know, all 4 of your channels into the power and the ground, but there are better ways to go about it. I, on my installs now, use a power distribution brick. And what that allows me to do is keep my wiring a bit more organized, A, and B, you know, the more power that you run through this controller, the hotter it gets. I'm not super worried about that for my applications, but I figure better to be safe and clean than sorry. So what we've got now, again, let's just review. Power going in, ground over here. Power going in and our ground. We've got power going out now to 2 channels through 2 JST connectors. We're grounding 2 JST connectors through the controller. And now the first JST connector to that first strip that I showed you is on channel 1, just the data. And then the second JST strip that I just connected has its data going to data 2. So now, when we give this power again, channel 1 is remembering what I told it to do last time, and it's just doing this little wave thing. What should we do about channel 2? Well, all we gotta do is plug it into the JST connector here. And there we have it, y'all. So now, when I go over to my app here, I can turn channel 1 on and off, channel 2 on and off. I can do them running simultaneously. I can tell all channels to do the same thing. So twinkle stars, whatever the hell that is. We've got rainbow. We can do it faster speed. What else? Comet stacking. Like we got options, y'all. But I'm getting besides the point. So just what we're showing here is that we've got both channels now plugged in. They're both wired up, and you can program them to do whatever you want, whenever you want. All that's left here is the triggers. So this controller has 4 triggers on it, 1 through 4. And basically what this allows you to do is tap something in your car. It could be the dome lights if you want, you know, your LED strips to do something special when your dome lights turn on. You can tap something that only gets power when the car is running. So these triggers open you up to a bit of flexibility to have the aftermarket lighting that you're installing interact with the vehicle and respond to certain triggers from the vehicle. So I'm just going to simulate that really quickly by the first trigger and seeing what these strips do to react. Obviously, I'm not in the car, so I can't tap a power source in the car and run it here. So what I'm just going to do is use these little alligator clips to simulate that. So what I'm simulating exactly is providing 12 volts of power to one of these triggers, and we'll see what happens. So I'm going to take 12 volts of power, and I am going to hook it up to trigger 1. And you can see it's acting as a turn signal. Now, if I do the same thing, over here we've got channel 2. Come on, sit nice. I can do the exact same thing on channel 2 and have it behave the same way. Now I can group my channels together. I can wire all these things together. Realistically, if I was going to do this, I would have both of these on the same channel so they both act as turn signals whenever they get a signal from the turn signal. Now, the cool thing about this controller is inside the app, you can have the triggers either do the preset trigger, which, you know, trigger 1 is your left turn signal, or you can turn it on and pre-configure what you want it to do. So let's say for this one, when it's getting a signal, I want to do red, green, and white. So I'll set it to that. And then whenever I provide power to trigger 1, it should, fingers crossed, do red, green, and white on that channel. So there you go. So basically, in a nutshell, for these controllers, you're going to provide them power, provide your strips power, and then for each strip or for each channel, you're going to provide data from the green wire. Bonus points, if you do want to do triggers, all you need to do is tap some power source that will tell this controller to do something. Whenever it gets a signal from that power source, it'll tell your strips to do that particular thing. That's it, y'all. So yeah, that's it, y'all. I hope you found this helpful. I think I was pretty thorough and covered everything from wiring to LEDs to controllers. So if I missed anything, definitely let me know in the comments. And sit tight for that interior wiring video. I'm gonna do that also, just so you know what goes where. But basically now when I say, you know, your controller goes here, you know, wire your controller, I'm just gonna say, if you don't know how to wire the controller, jump over to this video. So I can make that interior wiring video pretty clear and not slow you guys down. Any questions, any comments, any concerns, as always, let me know in the comments. Otherwise, be sure to hit that like button. Be sure to smash that subscribe button. It helps out the channel. I'm growing a lot faster than I thought I would, and that's thanks to you guys. So really appreciate you. You keep smashing those buttons. I'm gonna keep churning these things out. See you on the next one. Peace.